The first section we're going to cover is 7.1, linear and nonlinear systems of equation. Linear and nonlinear systems of equations. All right, so a system of equations is essentially a more than one equation. It's a grouping of equations. We can have two or more. In this section, we're only going to work with two equations. So the thing to note is that if you have two equations, you can have two variables and you can solve for a finite solution, meaning a numerical point. So let's start with an example. All right, so we're going to start with this right here. We have x plus 5 equals, oops, my bad, it's x plus y. X plus y equals 5. We also have x minus y equals 3. All right, so this is a system of equations. It's a system because we have two equations, two variables. So because, oops, variables, there we go. Because we have two equations and two variables, we can solve for a finite solution. So this whole chapter is going to show us multiple ways of solving these. But the way we're going to use in this section is substitution. We are going to use substitution in this section. So substitution essentially means we take one equation, solve for a variable. Does not matter which one you choose. The more you do, the more you'll realize which one it will make your process the easiest. So take one equation, solve for a variable, plug into the other equation. All right, so let's start with an example. Let's solve this example we have here. All right, so in our first one, we have x plus y equals 5, and we have x minus y equals 3. It is completely arbitrary, again, which one I take and solve and plug into the other one. Again, the more you do, the more you'll realize which one will make it nice, smooth process. Just because I'm choosing so, not because I see anything easy, I'm going to take this guy here and I'm going to solve for x. So if I have x minus y equals 3, if I want to solve him for x, I'm going to need to add y to both sides to get x all by itself. So when I do that, I have x, these cancel, is equal to 3 plus y. All right, so I have taken one equation, I have solved for a variable, I solved for x. My next step is to plug into the other equation. So it is very key that you plug into the other equation, not back into the same equation, because it's not going to get you anywhere. So I'm going to take this guy here, and I'm going to plug him into the first equation. So my first equation is x plus y equals 5. Well, I know that x in this equation is the equivalent of 3 plus y. So if I were to take that and let's sub him out for my x, you'll see what's going to happen. So instead of x, I'm going to say that's 3 plus y. Then I go back to my equation. So hopefully you see here what I've done, that this right here is equal to x based on the other equation. All right, so let's solve this. I can drop these parentheses. They really don't do anything for me because there's no multiplication outside. So I have 3 plus, I have y plus y, so that will give me 2y equals 5. So notice how I completely rid the equation of the x variable. This enables me to solve because I have one equation and one variable. One equation, one variable. So solving this guy for y, I need to subtract 3 from both sides. That will give me 2y equals 2. Divide both sides by 2. That will give me y is equal to 1. So now I have my y. Notice that I had two variables to begin with. I had x and y. So now I have to solve for x. Now my option here is to choose, I can choose either equation to plug this back into, this y equals 1. They both should give me the very same x solution. So let's plug it into, I'm going to take my first one, x plus y equals 5. Well, I know that y, according to this, is 1. So x plus 1 equals 5. Subtract 1 from both sides, x equals 4. Just to show you that this will solve the other equation as well, we have x minus y equals 3. So this was the first one, this was equation. This is the second equation that I initially had. And I said y was supposed to be 1, so x minus 1 equals 3. Solving for x, I would add 1 to both sides. X will give me 4. Same solution. And that should work that way. If it doesn't, you've got a mistake somewhere. So my solution in this case is x is, oh, sorry. I was going to plug in a number there. I was going to put it in coordinate form. X is 4 and y is 1. So this is my solution for this equation. All right, let's look at another example. Let's look at it. So this was a linear because this is, these both create lines when graphed. Both of these equations are linear. So let's look at a nonlinear. So let's look at a nonlinear system of equations. System of, basically this means that one of my equations, one or both, it doesn't matter, is not going to be linear. It's not going to form a line. In this case, I'm looking at x squared plus y squared equals 5. And then my other one will be x plus y equals 1. So this guy here, if I was in class with you right now, I'd say, who knows what this creates when you graph it. Hopefully someone will remember that this is a circle when both, if you remember the circle form, it was x minus h squared plus y minus k squared equals r squared. So in this case, my h and my k are just 0, 0. There's supposed to be an r over there. Okay, so this one is a circle right here. This one is a linear though. So this one will create a line. So my suggestion is to take the lower degreed equation and plug it into the higher, to the upper. So this is first degree. Both of my exponents are both 1s. So we're going to use the same method. Let's take this guy and solve for solve for one of my variables. Which one? It does not matter. I'll solve for x. So if I subtract y from both sides, I get x is equal to 1 minus y. So the steps are exactly the same. So now what I have to do is to take that x and plug it into my second degree there, my circle equation. So if I know x is really 1 minus y, I can plug that in. The parentheses are very important because the entire x is squared. So 1 minus y will be squared, plus y squared equals 5. So keep in mind, such a common mistake, this right here. If I was in class, I'd ask you, how do I expand that guy? So many people want to square the terms individually, distributing that exponent, but you can't. It is a binomial squared. You have to distribute this guy. So distributing him should give me 1 minus 2y plus y squared. So this guy right here is that quadratic right there, plus this y squared equals 5. So now I'm going to combine like terms. Notice that I have 2y squareds here. So that will give me, I'm going to put them in descending order because that's how I like it. The next one would be minus 2y, and then the plus 1 equals 5. So now I have to solve this guy. So if you can remember back to beginning of this course, you learned it in Algebra 1, but this is a quadratic. Remember I said if you can't factor quadratics, it's hard to move on. Here's an example. This guy here is a quadratic. So I'm going to solve him like a quadratic, which means I need to set him equal to 0. To set him equal to 0, I've got to bring that 5 over by subtracting him. So that's going to give me on my left-hand side 2y squared minus 2y. 1 minus 5 will be minus 4 is equal to 0. It is a quadratic. Notice that he is a quadratic and a is not 1, so that he's the more difficult one to factor. However, if you noticed, all of my terms have a common factor of 2. Common factor. And if you remember, I told you you can divide out a constant. Divide out a constant. If we were in class, I'd ask you, why can I not divide out a variable? And I think we saw that in that last, I want to say maybe the last test we took, the trigonometric, where we divided out, well, we would divide both sides by one of our trigonometric functions, and we lost a solution set. So we cannot divide out a variable. All right, but let's go ahead and divide out a 2. Why not? Makes it smaller. So dividing every term by, oh goodness, sorry about that. Dividing every term by 2, I would get y squared minus y minus 2 equals 0 divided by 2 is just 0. All right, so this is a quadratic that I need to solve, and my a is 1, so this one's a lot nicer. So remember, I'm looking for 2 factors of my c term, which is -2, 2 factors of -2 that will add or subtract to give me my b term. My b term is -1, so that would be -2 and +1. All right, so because my a is 1, I can jump straight into those binomials, y minus 2 and y plus 1. All right, so these 2 binomials multiplied together would give me this quadratic. So now I'm solving for y. So if you remember how we do this, I would ask you in class, what do I do next? And hopefully someone would remember I set each factor equal to 0. So y minus 2 equals 0, y plus 1 equals 0. Solving these, I get y equals 2 and y equals -1. All right, so I didn't solve for x yet, have I? No, I haven't. So I only got my y. So notice I do have 2, and that is totally fine. And that's because this guy was a second degree. He's a circle. All right, so if I need to find my x value, I'm just going to go with the simpler one here. X is equal to 1 minus y. So x is equal to 1 minus y. So I'm going to have to check for both of these. So I'll probably get 2 different x values. All right, so x, not probably, I will get. So let's try the first one. X is y minus 2. X is equal to -1. So this solution set is -1, 2. So my next one is x is equal to 1 minus y. And in this case, y is -1. X is equal to 1 minus -1. So that means x is equal to 2. So this solution set will be 2, -1. So I have two points. And we didn't really talk about this, but what this means is when I graph these two, these are the points of intersection. That's where these points are going to, these 2 equations, these 2 functions, well, actually a circle is not a function, but this is where the 2 graphs will intersect. Points of intersection, which makes sense why we would have 2, because if I was graphing a circle looks like this, and if I graph a linear, unless that line is totally tangent, it's going to cross through and have 2 points of intersection, here and here. The only way it would have 1 is if it was a tangent line. But this is not, so I have 2 points. That's why I have 2 points of intersection. And which is why up here, when I had 2 linears, you know, if I have 2 lines and they intersect at one single point, they can only intersect at one point. Okay, I believe that is the gist of 7.1. So we're gonna stop here, and your homework is gonna be on WebAssign.